In this video, we will demonstrate how to calculate the limiting probability distribution for a discrete time Markov chain within an infinite state space, which denotes the number of people waiting in line at a ski lift. The context for this problem is ski lift operations at Copper Mountain Resorts, a large ski resort located in the Front Range of the Rocky Mountains in Colorado. Specifically, this distribution may be used to evaluate the number of customers waiting in line at a regular or high-speed chairlift and used as a decision tool for selecting between the two.
So my name's Catherine Bush. I'm the PR coordinator here at Copper Mountain. Copper is located about 75 miles west of Denver in the Colorado Rocky Mountains. We have world-class skiing terrain. We offer several amenities and activities for families in our resort, in our village area. Tubing hill, a winter zip line, plenty of dining and convenient lodging located in our base area. So one of the things that sets Copper Mountain apart is our naturally divided terrain. The East Village offers our expert and advanced skiing and riding. And then as you work your way west, the slopes get naturally easier, which actually separates skiers and riders by their ability levels, which creates an overall great experience for our guests. We have terrain parks and one of the first super pipes to open in North America, which usually opens around Thanksgiving, and it's host to several events throughout the winter season, including the Grand Prix, which is a Winter Olympics qualifying event, so that's pretty unique to Copper. So this actually, this season marks our 40th anniversary since we were founded in 1972 by Chuck Lewis. Basically the story is he saw the area, visited Summit County, Colorado, and saw the area and envisioned a world-class skiing resort and made that dream happen just by working with the U.S. Forest Service and then several funders in the Denver area, and opened up our mountain in 1972. We had 6 lifts running for that first season. Our opening day hosted around 170 guests. So definitely we have evolved since then. The first couple of years there was no lodging on site. It was purely a ski and snowboard destination, but we've certainly evolved since then, and we're excited to open our season on November 2nd for our 40th anniversary. The area is one of the biggest areas in the United States for skiing and snowboarding visitors. I think Colorado in general, 20% of all skier visits over the last year were visitors to Colorado. So one of the things that makes us unique as well is the fact that we have Frontline Assist, which basically is a program that we've introduced over the past year or two to help with the fluctuations in our busy times and staffing needs. So we have upper management, anywhere, our CEO included. He comes out and assists with all of the departments that need some extra help during those busy periods. So parking, we're out parking cars, we're serving pizza at Solitude Station, which is our mid-mountain restaurant. Yeah, we're all hands on deck during those busy times. So we operate both in the winter and the summer seasons, which many people don't know that we also offer mountain biking, hiking, and then several activities geared towards families in the summertime. We've got a climbing wall, go-karts, a zip line, things like that really cater to families. And then nearly every weekend in the summer we're hosting events that range from adventure races to yoga festivals to music festivals. So there's something going on every weekend at Copper during the summer. And then in the winter we operate from November through mid-April. And we offer world-class skiing and events. The Grand Prix, we host that. Sensation is our annual music festival towards the close of the season, and everything from on-mountain music to skiing, snowboarding events, a winter mountain bike race. So one of the biggest challenges that we have, both Copper and the industry as a whole, is the variability of weather, because it's obviously not predictable, so that presents some challenges for us as far as snowfall. If it snows, we tend to see great skier visit numbers. If it doesn't, then people tend to choose other activities instead of skiing and riding, but that tends to be one of our biggest unpredictable factors. But some ways that we tend to combat that is by offering après-ski activities, the tubing hill. We have one of the best snowmaking systems in Colorado, so even during the early season when we might not get as much snowfall, we consistently have great snow and great terrain that people still enjoy.
Suppose that Copper Mountain is interested in the probability distribution of the number of people waiting in line at one of their ski lifts during a peak interval of time during the day. Knowing this distribution can be useful in making decisions about whether it would be useful to add capacity at the lift by speeding it up or adding more seats to a chair. Though the problem presented in this video is representative of one in that industry, keep in mind that all data given in this video are fictitious and for illustrative purposes only. Suppose that a particular ski lift has a chair that passes by every 5 seconds. Every time a chair passes, a waiting group of skiers or snowboarders jumps on if the line isn't already empty. Between passes of the chair, there are also groups of skiers that arrive to the line. Upon examining the number of skiers and boarders waiting in line immediately after a chair leaves, it is noted that the lines decrease by 1 with probability 0.3, stays the same with probability of 0.5, and increases by 1 with probability 0.2. Note it is assumed that between passes of the chair, no more than one group of skiers or boarders arrives. As an example, the probability that the size of the queue is the same immediately upon a chair departing the ski lift is equivalent to the event that one group arrived in the 5 seconds since the last chair left and one group jumped on, or that nobody was waiting in line when the chair came. Copper Mountain may add capacity to the lift by speeding it up such that a chair now passes every 4 seconds. It is hypothesized that the probabilities of line changes for this faster lift will be given as follows. The problem is to first determine the effect adding a high-capacity lift on the limiting distribution of the number of customers waiting in line. Specifically, what is the probability of there being 0, 1, and 2 groups waiting in line immediately following chair departure for the regular and high-speed chair lifts? What is the expected number of groups waiting? Let x of t be a Markov process given by the following. With the one-step transition probability matrix given in general form as follows, where A0, A1, A2, and A3 denote the probabilities given above for either the regular or high-speed chairlift, and A0 equals A2 plus A3. From the Chapman-Kolmogorov equations, the following is true. Multiplying the jth equation above by s to the power of j yields the following. Summing down these equations and denoting p of s as the probability generating function for the discrete random variable x of t, it follows that this equation may be shown to reduce to the following. The probabilities of x of t being equal to 0, 1, and 2, and the expected value x of t for the regular and high-speed lifts may be found through differentiation.